Today, we'll explore writing linear functions from a graph or a table. In this video, we're going to look at how we can use data points from a graph or a table to write an equation in slope-intercept form. By the end of this lesson, you'll be able to confidently write equations from graphs or tables. To write a linear function, we use the slope-intercept form of a line, which is y equals mx plus b. Here, m represents the slope of the line, and b is the y-intercept, where the line crosses the y-axis. The slope tells us how much the y value changes for every 1 unit increase in x. To find the slope between 2 points, we use the following formula. This formula calculates the change in y, which is also called a rise, divided by the change in x, which is called the run. In our case, the slope equals 1. Once we know the slope, the next step is to find b. The y-intercept b is where the line crosses the y-axis, or where x equals 0. Therefore b equals 1. If you can't see it directly from the graph or table, you can substitute a point from the line into the slope-intercept equation to solve for b. As we already have the slope m is 1, we have now y equals x plus b. We now start substituting any chosen point from the line and we will find b. Let's see how this works with an example where we need to determine the equation of the line shown on the graph. To write the equation of this line, we need two key pieces of information: the slope m and the y-intercept b. B, which is the y-intercept, is where the line crosses the y-axis. From the graph, we can see that the line crosses the y-axis at the point 0, 2. So, the y-intercept b equals 2. As we know, the slope m represents the rate of change or the steepness of the line. To find it, we can use these 2 points on the line. The formula for slope is the following. Let's start by substituting y2 minus y1, which is 5 minus 2. Now, divide it by x2 minus x1, which is 3 minus 0. Therefore the slope m equals 1. Now that we found that m equals 1 and we know that b equals 2, we can write the equation of the line in the slope-intercept form. Since the slope is 1, we can simplify the equation to y equals x plus 2. As you can see, you found the equation of the line based on its graph. Now that you've learned this, you can solve more challenging examples. In this example, we need to determine the equation of the line in slope-intercept form from a table. We will start by representing the points on the graph for a better understanding. Now to determine the equation of the line, we need to find the slope m and the y-intercept b. Let's start by finding the slope. We can calculate the slope by using the 2 points given in the table, using the same formula we used in the last example. Next, all we need to do is substitute the values from the table. We start by subtracting 8 from 4, then divide it by 3 minus 1. As a result, the slope m equals 2. Since we've determined that m equals 2, our next step is to find the y-intercept b. We can use one of the points from the table, such as this point with the following coordinate 1, 4, and substitute it into the slope-intercept form, then simplify the equation and see that our result equals 2. We can now substitute it into the slope-intercept form. We've successfully determined that the equation of the line is y equals 2x plus 2. Now that we've practiced with both graphs and tables, we're ready to apply these skills to more complex problems. In this problem, a car rental company charges a base fee and a per-mile rate for renting a car. The graph will show the cost in dollars y as a function of the number of miles driven x. We need to determine the equation that represents the relationship between the cost and the miles driven. To determine the equation of the line, which represents the relationship between the total cost and miles driven, we need to find 2 things: the slope m and the y-intercept b. We'll start by identifying 2 points on the graph by reading from the axes. The y-intercept is the point where the line crosses the y-axis. In this case, the y-intercept represents the base fee charged by the rental company before any miles are driven. From the graph, we can see that the line crosses the y-axis at 0, 2, meaning the base fee is $2. Now, to find slope m, let's find another point on the line. Looking at the graph, the line crosses the x-axis at point 40, which tells us that after driving 4 miles, the total cost is $0. This means the company breaks even at this point, and that any miles driven beyond that count as profit. The slope represents the rate of change in cost per mile driven, or the cost per mile. Now that we have the 2 points, we can use them to calculate the slope. Let's write the formula needed. Let's start by substituting y2 minus y1, which is 0 minus 2. Now, divide it by x2 minus x1, which is 4 minus 0. Therefore the slope m equals minus 1/2. Now that we know that m equals minus 1/2 and we know that b equals 2, we have the equation of the line in slope-intercept form. As you can see, the base fee is $2, and for every mile driven beyond 4 miles, the cost decreases by $0.50 per mile. Keep practicing, and you'll be ready to solve even more complex problems. Let's recap what we've learned today about writing linear functions from graphs and tables. Whether you're working from a graph, a table, or a real-world scenario, the process of writing a linear equation is the same. Identify key points, calculate the slope, and use that information to find the y-intercept. In summary, whenever you are asked to write a linear function from a graph or a table, remember to always start by identifying 2 points to calculate the slope using this formula. Next, use one of those points to find the y-intercept by substituting it into the equation. Once you have both the slope and the y-intercept, you can write the equation in slope-intercept form. Remember that the slope tells you how quickly y changes in relation to x, and the y-intercept gives you the starting point when x equals 0.